Yeah. That's a great question. I'm not entirely sure where you will use it in your life. It's often used in statistics. We are on page 21. 21.
Have we done everything for this?
Yes. No, not necessarily everything in the packet. Like, we didn't do this game yesterday, but every notes before this we've done. Okay? Yes, the 5.2 notes in there is long. It's actually a 2-part notes because I did some before lunch, some after lunch. Okay, so with logarithmic functions, just to review, whenever we have one of our formulas, I'm just going to zoom in. We have a log. We say this is base A of x. So the log base A of x, okay, is how we would solve that. What did we say yesterday? What is our inverse of a logarithmic function? Oh. Anyone remember what we call it? So here's, oh my goodness, I need this to be nice. A log, if we have log base A of x equals y, do you remember what our inverse would be there? Remember we started with our base? How do we rewrite this? A
Over y.
Perfect. Raised to the y equals x. Okay, so that's it rewritten. That's its exponential form. Now remember, are these identical? Are these the same thing? No, what are they? Inverses, okay? That's the key. These aren't the same, they're inverses of each other. Okay, so here's just the general formula, okay, for a change of base. Notice here, the name in and of itself is going to tell you what exactly we're doing. Change of base, okay? Obviously, we're going to change the base. So here, my base started as A. Now, when I write my new fraction, my base becomes a B. And where do you notice my A and X go? They're not lost. They don't go away. Where do they end up in my fraction? They both become my big numbers, okay? The base moves to my denominator, okay? So we're going to change the base of the logs, put it in a fraction. My big number stays up top as the big number. My base becomes the big number in the bottom, okay? Now, why do I bring this up? Because you don't have a scientific calculator. We only have graphing calculators, which means you can't just type in log and then pick a random base. Okay, you just can't pick any base. Yesterday, we talked about base 10. When we have base 10, Ian, you all right back there? Is it working?
Yeah, it's good now.
Okay. All right. So base 10, remember when we have base 10, we don't write it, right? So we talked about yesterday how there's an invisible 10 right there in our logs, okay? Base 10, just log, is found in your calculator, okay? We have that button. It's on the side. So this is why we would use change of base formula, okay? For this one, notice my base changes to a 10. My x comes up top, my a goes on the bottom. Okay? What's the other kind of logarithm we have on our calculator? We have common log. What's the other one? ln. What did we call ln? What was the name for that one? Anyone remember? Natural log. Okay? This is our natural log, right? ln. So ln is the logarithmic function with base e, right? We write it a little different with our ln. Okay? So if we just zoom out here, again, the reason we do change the base is because if I give you log of 3x, you can't type in log base 3 in your calculator. Okay, we can't do that. So we would need to use our change of base. We have to get it to a point where we can actually type it in our calculator. Okay? So for example, I could make this up top. I could change it to be common log, where I put my base in the denominator and my x in the numerator. Or I could make it natural log. Okay? The key is we change both our numerator and denominator logs. We have to be the same. Okay? So we either change them both to log base 10 or we change them both to natural log. Okay? Our x goes up top. Our y goes in the bottom. Not our y, our base goes in the bottom. Okay? Now we're talking a lot of abstract. Let's just actually apply this, and I think it'll start to make a little more sense. Okay? All right, so here up top it says, rewrite the logarithm as a ratio or as a fraction of common logarithm. Remember, common logarithm has base what? Nope, other one. 10, right? Base 10. That's our common log. Natural log is what you were thinking, Blake. Base E. Okay? Natural E, common is 10. Okay? So first, let's do that stuff. Let's rewrite it. So if you were to get this question, you can't just type this in your calculator. Okay? We can't do that. We don't have a log base 4 option. Okay? However, we do have common log. So if I change this log 4, if I just change it and I make it into a base log or common log, just got to do it in both. I'm just going to change it. Now I'm going to take my base and put it in the denominator and my big number and put it in the top. Okay? Okay, that's writing it as common log. We also could rewrite it with our natural log. So I would just need to make the numerator and denominator natural logs. My base goes in the denominator. My big number goes out front. Okay, so those are equivalent ways of writing it. That means the same thing. Now we're able to simplify this because we can type in... Yeah.
Wouldn't it be log 4 over log 25?
Nope. We want to put our denominator in our base in the denominator. The 4 right there goes in the denominator every time.
Oh, yeah.
Okay?
So log and ln are the same.
Not, well, kind of. Ready? This is ln is just another way of writing log base E. Okay? So it's still a log. We just write it ln just because it's log natural. Natural log has an N. There you go. Okay. Now we can actually simplify this. So let's just do the top one for a second. Let's prove to ourselves that we can do this. If you hit that log button on the left side, just do the numerator. Hit the log, type in 25, hit enter. You should get 1.39794. Notice I haven't rounded it. I'm not rounding it yet. I want a lot of decimal places at the beginning. Okay? So I'm just going to pick 4 or 5 decimal places. That's just the numerator. Yes? Easy. That's because you can't do both at the same time.
So what do you
Oh. No. You're fine. You're fine. You did everything. I just did the top. Hold on to that number.
okay. So
Yes.
So you're using the
Yeah.
common log.
Yeah, just do the top. We should still get that number you have right there because you typed it in right. All right, then we type in log of 4, and you're going to get 0.60206. Okay? then we'll divide. So we do top, then we do the bottom, then we hit divide. You should get 2.322. So sometimes you'll be able to type it in like the whole thing correct and you can get the right answer. I just caution against it just because I've noticed a lot of kids put parentheses in the wrong spot, they make a silly error, and then they don't actually get our final answer, okay? But you should, if you did this whole thing in one step, you could end up with our final answer. I, again, just caution against it. I do the top, then I do the bottom, then I divide, okay? Try your calculator one more time. I want you to test it with this one, with our natural. You should get the same answer at the end. So get the practice trying with your natural log. You should get 2.322 when you're done.
Wait, so how is it the same when log and ln are different?
That's just because it's our change of base formula. Because the bases are the same, it doesn't matter. Okay?
Oh wait, we have to write the numbers like this. Yeah.
All right. Is everyone getting our 2.322 with the natural log? Okay. Go ahead, I want you to try B. Remember, our first step is to rewrite it. Not just in one way, but in both ways, with the common log and the natural log. 2.322. Come on, Blake.
Did you see that? I'm
Blake.
actually trying to do work and he's distracting me.
All I did was walk up to him.
That was a very disrespectful gesture.
I didn't
Wait, so whenever you put it in like the division,
Mhm.
use LN, and not like one.
Yes, use your LN button.
How do you know that is?
That's a problem. We're going to need to know that. Log, LN. All right, so here it is written as the natural logs. No, sorry, not natural logs. The common logarithmic, base 10. You also need to make sure you write this. It doesn't have to be written exactly like this. We could do it up and down like I did up here. Okay, or you can write it next to each other. And then I think we should get like 3.585. Is that right? We getting that? Okay. That's your answer. Anyone not get that? Because remember, on your test, I can't help you with our calculator. Okay, we're all okay. We see where we get that.
Wait, on the test, are we going to have to do both?
If I ask you to do both, yes.
We just have to write like what you did there?
Yep, you can just write exactly that. Okay? All right.
Wait, is both check? Because like, is it also like a checking thing? Because one might work, one might not work, or both?
They both always should work. Yep, it's not one or the other. All right, go ahead, copy this down up top. Just says, recall the logarithmic function with base A is the inverse function of the exponential, which we talked about on the last page. All that saying, log base A is the inverse of this. Okay? That's all that's saying, is that these two things are inverses of each other. Okay? Which, again, those of you who missed yesterday, this is what we spent a lot of time on yesterday. Okay? So that's in our video. You might want to go watch that. In fact, you should go watch that. Okay. This next part, it's going to be a lot of writing. Okay? Just warning, but you're going to want to have it. I'll zoom in. Now, with logarithms, what I told them yesterday, and we had some rules yesterday. We're going to have some more rules today. Okay, these are rules that you need to know. Okay, I'm not giving them to you on a test. However, they always look more, confusing written out like this. As soon as we start to use them, you'll just start to remember what the rules are. our formulas can just be hard because there's no numbers involved, just a bunch of letters. But go ahead, copy this down, and I will explain what it means in a minute.
What is the third one?
We'll talk about it.
Doesn't even make sense.
TSBMF.
Next thing you know, there's gonna be like 6 in a row. Look at how hard it is.
Crazy.
Beyond that,
Why are we learning this? What does it have to do with like genuinely, like what does this help you do taxes? Does it help you like
Statistics, for sure. I'm not sure how it might help you. You might use it one day in your career, you might not, but it's part of Algebra 3, and so that's why we're here.
They should just
I mean, it's a good way to engage your brain, but like, this is too much. The UH, I don't like the UH.
I'll look tonight. I'll figure out what ways we might all use logarithmic functions one day in our life. I'll report
I
back.
mean, no,
I'll ask
it's like, I think it's like a
Yeah,
good
go
way-
ask ChatGPT.
I got you.
It's a good brain exercise, but like the U and that, man, that's just crazy.
So many letters. Who knew? There's no numbers in these. All right. What'd it say? When are we going to use this?
Scientific context.
Yeah, that's actually true.
So,
A lot of scientific contexts.
experimental growth or decay.
Yep.
pH scale in chemistry.
Yep.
Earthquakes. Sound intensity, like decibels.
What is your name, Kyle?
Algorithms, like data comprehension. Financial modeling.
So there you go. There's your list. One day, maybe you'll do one of those things. Okay, let's talk about these rules, and I promise they'll start to make a little more sense. Simply put, if I have the logarithmic function of two things that are being multiplied together, I can break it apart and then add the two separate logarithmic functions of those things. Okay, so the log base A stays. I take the two things that are being multiplied, I split them up, and then I add my two logs. That's what our first rule is saying. So down here, 3 times x, log base 2. I just make both log base 2. I keep the base the same. I don't change it. And now I just split my two things inside up, and I add them. Okay? Opposite is true with division. Okay? Up here, we're multiplying, and we added. Down here, we're dividing, so we're going to subtract. Everything else stays the same. You just need to know we multiply, we add. If I see them being divided, we subtract. This last one that Ian thinks is crazy, all this is saying is I have the log base A of a number raised to an exponent. I can just take that exponent and put it right out front and multiply it. I can just totally move it to the front. Okay? That's all this one's saying. Just like down here, log base 2 of x stays the same. The only thing that happens is I take my little exponent and I move it to out front and multiply the whole thing. Okay. The next side, natural logs. Now, it's all the same. It's the same rules. We just have L of n now. Okay? You can take a picture of it. I probably should have told you before you were going to need to make more room. But feel free to just take a picture. Here they all are in one spot. If you want to write them down because you'll learn them better that way, go for it. I'll give you the time.
I mean, actually, that's
What do you say?
Like this whole room was made through like math and stuff like this.
Yeah. Look at you. You're such a mathematician. You're already thinking that way.
Is that how drugs made like math?
Oh yeah, there's a lot of science and math behind making drugs.
Really? You can make drugs with this.
I haven't, but
I'm sure.
Why wouldn't you? I mean, they lab on drugs.
well, there's so much chemistry involved in just cooking. So I'd have to believe that there's
You know chemistry and math.
your options are endless. Okay, so again, I'll say this one more time. All of these rules are the same. We're just talking about natural log now.
Wait, you wanna like
Okay.
do, like, what's that one show? Breaking Bad, like IRL. Did you see that Pablo Escobar's son escaped Thomas?
Today's notes are a lot more about just copying things down than actually doing the math.
No, his son is now doing the same.
A lot of just hand copying.
No, his son.
All right, so again, yes, how are we supposed to remember all this? Do your homework. That's the first part. As you practice it, it's just going to become second nature. If you want to make flashcards, go for it. If you just want to stare at this a little bit every day, go for it. But you do have to know all these rules on the test, okay? I'm not going to tell you. Nope, you will not have a sheet for these. Nope. No formulas for these ones, okay? You have to know them. What? That's literally the whole point of this section. 5.3 is knowing the rules.
Actually, like,
All you really need to remember is that the
I know. I'm sorry. That's what we have to do. I could just change it, but I'm not going to. All right. So let's start practicing. All right. Write each logarithm in terms of ln of 2 and ln of 3. So I'm kind of helping you out here. I'm kind of giving you a goal. You've got to figure out where I see a 2 and where I see a 3. Where can I pull a 2 and a 3 from? 6. How would I break a 6 down into a 2 and 3? How could I rewrite it? Yeah, right? 2 times 3. So if I just copy this down, I can write 6 as 2 times 3. Okay? So ln of 2 times 3. Now, how could I break it down even more? What rule could I use here? Which one? What? Yeah, the first one. Right? The first one up top says, if I'm multiplying two things, I can rewrite it as an addition problem. Okay? So yep. So I leave my base the same. Here's my addition problem. Base stays the same. Natural log of 2, of 3. We add them together. That's it.
Wait, do you not like actually do it?
Nope.
Mr. One.
Yes.
It's like equals each other. Why would you just like make that problem like one? It's so much easier to see.
Because today we're expanding. Tomorrow we're going to do the opposite. Tomorrow we're going to put things and make it smaller. Today we're expanding. Yes.
Doesn't make sense because if it says like log A,
I really don't want to do this tomorrow.
Yep.
yeah, but they're both A. If A would be just the bottom number.
The base.
This one in log.
Yeah, that would have to do 3.
What happens like to this 3?
Oh, that one of them is E, one of them is
Yes. Well, I'm kind of using this one specifically right here.
Oh, also.
Okay? Yes. Okay. Yes.
So the answer is just the application.
Mhm.
So it's not the ln 2 times 2.
No, this when I have it totally expanded, that's my answer right now. Okay? Good question. So again, today we're expanding, we're making it longer. Okay? Tomorrow we're going to be making it shorter. Okay? All right, let's try our next one. Okay, I have ln of 2 over 27. What rule can I use here? 1, 2, or 3? The quotient property. What is the quotient property there?
You're gonna like subtract them.
Right. I leave my base the same. What goes first, the 2 or 27? The 2.
Wait, but it says write each logarithm in terms of 2 and 3.
Right. Do I see a 3 anywhere, Ian?
You could divide them to 27.
Oh my gosh, Jacob, you're on a roll. Okay. So, let's pause. Let's pause. Let's go a little slower. Are we all okay to hear? Okay. Now, Jacob brought up a good point. I don't see an ln to the 3. Okay? That's my goal, is to see an ln to the 3. So Jacob said we could break this 27 down. We could divide it by 3. Is there another way I could break it down that's related to a 3?
Indubitably, yeah.
You could 3 to the power cube.
Close. Cubed. Yes, you were right. To the power of something, power of cube, right? So I can rewrite 27 as 3 to the cube root. Okay?
Wait, do the other power.
Yes, what's the other power property, Ian?
Oh my. Best.
Which one are you going to use? 1, 2, or 3?
3.
3. What does 3 tell me I can do with my exponent?
Put it in front.
Put it in front of the whole thing or just this one? Just this one. So I have ln, the 3 of n. Now this is confusing because they're both
Oh my god.
3s. What I just did is what I'm doing in green. I took my exponent and I put it out front.
What the Riz?
That's what that step was. Okay, so I'll just rewrite this in different colors so you can kind of see what we just did. We just moved it. I'm bringing the rest down.
Wait, but can we just make it ln?
Okay, that is it most simplified. Okay, most expanded. Yeah.
So is this like natural logarithm or logarithm?
Yes, this is natural log. We could have done this whole thing. If I gave you this, if I gave you that, we'd do the same things. Instead of ln here, we would just write log. We're doing all the same thing. It's just we have to keep this consistent from the beginning. 1, okay? All right.
Why do they make ln? Why do they do that?
Just because mathematicians are lazy, and so they want to write as few letters as possible. So rather than writing log base e, they just decided to do that instead. And it means the same thing. Okay? Yeah, Patrick.
So why did we do the thing in the example above, with 27, break it into just 3 and 9?
Wait, I said that again. Which part?
Like we did in the example above
Oh.
with the ln 27. Why
Mhm.
don't we just break it up into 3 and 9? Why don't we do the exponent instead?
You could do that. You'd get to the same answer as long as the reason I did it this way was because I want to see ln of 2 in there also, and so I pulled that out first. That's just because my directions told me to do that. Okay? But there's multiple ways to get to answers, so you could do that.
So how
Okay.
do we do it with ln?
He's talking about like make this a 9 right here. Like 3 times 9. So for example, if he did ln 3 times 9, and then we add it from there, that's what he's thinking. He could get there.
That's
Yes. You okay? Okay. Yes, here, just to prove that. Here we have 3 times 9. I'm going to go kind of fast, Patrick, through this, but I want you to see that it could work. So we rewrite it. Okay? Then I'd have to rewrite this. Patrick, you watching?
Yeah.
I'd have to rewrite him. Is that 3 squared, right?
Okay.
He becomes a 2. But now I'm combining like terms. So I really have 3 of these. You'll end up in the same spot, but you can do that. Okay?
What?
All right.
You're a fool.
Now, look at these next problems. We're almost done. We're going to do 3 and 4 and then be done with notes for today. Okay? So find the exact value of each expression without using a calculator. Okay? Now, here's a good first rule of thumb. If you have a radical, your first step is to rewrite it with an exponent. Okay? If you have a radical anywhere, just rewrite it as an exponent. So, for example,
You tried.
I've got log base 5. But then how could I write that radical as an exponent? What would I write? 5 to the what? Not to the 3rd power.
Oh my god.
Remember, if it's a radical, it's a fraction. Yeah. I was confident in you.
Why is your 2 5?
1/3. Because one's the base.
Oh.
One's my base right here. The other is my radical one.
Is
Okay.
that 5 like a regular 5 or like a square 5?
Which 5? The pink or yellow?
Pink.
The pink one?
Yeah.
It's a regular 5, but remember I'm raising it to the 1/3 because I'm taking the cube root. So I'm rewriting it. So it's 5 to the 1/3. Okay?
Oh my.
Is that okay? We're just rewriting our radical. We did this a while ago. Okay. Now, think back to yesterday. Those of you who weren't here, you'll see this in the video. Look back in your notes. There's a rule that's happening here that's going to make my life a lot easier. Right.
So you just subtract.
Yes. So, first of all, let's move our exponent. Let's use our first property. I got ahead of myself. So I move my 1/3 to the front, right? Because it's my exponent. I can rewrite it. So my 1/3 comes out front. Now I have log base 5, 5. Yesterday we talked about a rule where if my base is the same as my big number, what does that simplify to? 1. Good. That becomes a 1. So I really have 1/3 times 1, which is just 1/3. That's my answer. Okay? So again, this is why I'm not giving you your formulas, because this whole thing is about using our rules and properties to solve. Okay? So we have to know those to solve. That's what I'm testing you on, is if you know them.
Why is
Okay.
the log word? Oh wait, I remember.
From yesterday? Yeah. If I have the same base as the same big number, the whole thing becomes a 1. It goes away, basically. Okay?
Like, do you want to get shamed?
All right, I want you to go ahead and try B. Let's see what you can do. Try B on your own. How could I simplify this without a calculator?
You could just delete it.
When you're done, if you want to test it in your calculator, you can. You can type this one into your calculator, but I want you to simplify it without one first.
Where you
6,
Like,
6,
reverse,
6,
like, put like a square root.
minus.
Don't ever make a square
Would
root.
it be 4
No, no, no. We don't want radicals. Only exponents.
Would it be
Good
4
question.
Would it be 4 LNE?
Okay, close. Think about what the base of ln is, Ian.
So it's the same, so you can subtract the outcome.
Oh.
So then
Oh,
it's just
wait.
ln E4.
Close.
But we don't know what E is.
E is an actual number. It's like pi.
Is it E to the, like, powerful?
Would you divide? Divide. Oh, okay.
You could. If you went backwards, we will talk about that option. That's possible.
That's messed up.
Is E exactly like pi?
Not exactly. It's a different number, but you actually have an E button in your calculator. Like it'll spit out a decimal. Okay. So let's rewrite this one first using our new properties. How could I rewrite these using the properties we talked about today? What could I do?
The power one?
The power one. So I'm going to move my 6 to the front. So I have 6 ln of E minus 2 ln of E. Okay, so that's just what we did today. Now, let's pause for a second. Remember, don't write this. Or you could, actually. ln of E is really log base E to the E. What did we just say we could do whenever we have the same base and number? Yeah, they go away. Okay, they cancel out. It's really a 1. So really what I'm left with is 6 minus 2 equals 4. Okay, so some of you are close. Some of you are saying E to the 4. Yeah.
Bases are the same, can you just subtract the exponents first?
Yes. You basically did all this. You just did it really fast in your head. Okay. Another way you could do it, because I heard Elaine bring it up. Okay, Elaine recognized that we're subtracting, but if I were to go the opposite direction in my... Oh, I don't have my properties anymore. If I were to go to the opposite direction, I could write these... Oh. I could write these like this, where I take e to the 6 or e to the 2. Okay, I just kind of did the reverse of the property. I went backwards. So you could absolutely do this. If you were to do this, we can simplify my exponents by doing 6 minus 2 and get 4. And then what happens to my exponent? I bring it out front. So I have 4 ln of e. Those go away, so I'm just left with 4. So you get the same answer. So a lot of these, there's a couple routes you can go with our properties. Depends on the order that you use them. Okay, but you should always get to the right answer if you do the correct properties. Okay? Any questions on that one?
No.
All right, last one. 4. Okay? We're going to do A and B and then we're done. Okay? Like I said, today we're expanding. Tomorrow we're going to condense, I think is the word we use. Yeah, we're going to condense. We're going to make things smaller. When's the test? On Monday.
Oh, that's not.
Monday.
I know. Listen, we talked about this.
No.
We talked about this. It was either have a test Monday or have a test on Tuesday after Memorial Day.
Like the hardest
Oh wait,
test I have
is
on my
Memorial Day
course.
on Monday?
Not this Monday. What?
Oh, shit.
You want to take the test on Friday? I don't know that that'll go well for some of us in here.
No, that's not gonna go well.
Okay. Expand each logarithmic function. So, expand. When you see that word in the directions, that means we're going to make our problem way longer than we have it already by doing pluses and minuses and all that jazz. Okay? The first thing we should look for, multiplication and division. So, do I see multiplication or division?
Unfortunately, you see multiple.
Multiplication. Why are you such a Debbie Downer about that? I think it's easier. All right, so now let's rewrite it.
Hey, is it multiplication?
When you rewrite it, our bases all stay the same. So I have log base 4 of 5. Log base 4 of x cubed. And log base 4 of y. Okay, so all I did was I took all my terms that are happening in here and I split them up. Okay, I took everything that's being multiplied together. I'm making one big addition problem. Okay? That's our first step. When we expand, you constantly have to ask yourself, can I apply any more properties? Can I apply any more properties? So, look at our first one. Can I apply any more properties to this? No, my bases aren't the same, right? My 4 and 5, they don't match. It's not like I can make it a 1. He can't be split up into anything else. He's also not a hidden division problem. And he doesn't have a secret exponent. All right, what about over here? What about my middle term? Can I simplify him anymore?
Yeah.
Yes, what could you do?
1/3.
Okay.
Power 1/3.
Okay, so yeah, we've got a power of the 3. What would you do with that power of the 3?
Oh, no, you put it out front.
Yes, we put it out front. Good job over there. Okay, move it out front. So I have 3 log base 4 x. Okay, and what about the last one? Can I do anything to him? Nope. So we leave it the same. Okay?
You can make it,
Nope. Sorry. Shutting you down.
Why can't you do that for 5?
Why can't you for 5?
Do a log 4, 5.
So, can I multiply 2 things to get 5 that aren't 1 and 5?
No.
No. Can I divide things? No. Is 5 really like a 5 to the, like, is there any number raised to the power that could get me to 5? Like that. Could I figure out a value for x? No. That's why we know we're done.
Wait, so scroll back up. Why is it like that for the
Okay? We moved to the 3 because I still had an exponent up here. Okay? That is my fully expanded answer. Okay, as soon as you're done, it's a fully expanded. That's your final answer. All right, last one here. Go ahead and start this one. See where you go with this. How could you expand it? Remember, start with your multiplication and division. See if there's anything you can split up that way. Then see if you have any hidden exponents. Yeah.
We're gonna be locked in on Friday, Colin.
What the heck is happening?
For a few days or-
There's a lot
I
happening.
have no idea what's happening right now.
So first, do we have any multiplication or division?
Yeah, we have square root of 3x over 5.
What? Do you have we have division, right?
Really?
How could you rewrite? No. Don't get rid of it like that. Use your properties. When you are dividing, how could I rewrite it?
I don't have anything for the right side, so you
Not. Oh yeah, the quotient property. Yep, you're fine. So how would you rewrite this? Or would we add or subtract? Subtract. Okay, so we have the log of our top minus the log of the bottom. Okay.
that's fine.
That would be wrong. How about my city?
Oh, come
Okay. I know some of us are still working, but I want to go through this answer first before you guys keep going. All right, so I see the quotient property. Okay, I heard some of us say that. So I take the top minus the natural log of the bottom. We okay on that one? That's always the first thing to look for. Quotient or product property. From here, can I rewrite any of these with an exponent or with multiplication? Yes. Which one could I do, Margaret? Yeah, how would I rewrite that?
Would you just put the 2 in front because it's going to be an exponent or down?
Okay, so kind of. You're like one step ahead.
Well, you put the square.
Right, I'm going to write it like this. Now remember, it's not a square. If it's a square root, it's a half. Okay? If you see a radical, your exponent is a fraction. Okay? I'll say that again. If you have a radical, your exponent is a fraction. Okay, so we just rewrote it.
That's good, Dan.
And now I'm going to pull it out front. Okay, so now I'm going to take my 1/2, move it out front. So I have 1/2 natural log of 3x minus 5 minus ln of 7. Now, when we look at these, can I simplify the 7 anymore?
No?
Nope, he's done. This is actually our final answer. I'm going to talk about one last thing that I see a lot of kids do for some reason. Okay? They see this minus right here, and they automatically think our quotient rule, and so they'll do 3x over 5. Okay? How is this different than our quotient rule? What's different about this than what our quotient rule says?
Try that.
Right. So our quotient rule would say this right here that I wrote in pink is really that, where I have an ln on the 5 also. I don't have an ln on the 5. Okay? My natural log is on the entire 3x minus 5. Okay? So these are different. So don't simplify this with a fraction. Okay? All right. Any questions for me on that last one? So, today is expanding. Tomorrow we are going to condense. And then Friday we're going to review. And then Monday is our test. Okay? Now, I'm not telling you that to make you panic. That's not the goal. Okay? We're going to do a lot of practice. Okay? But I am telling you that because today in your packet... Oh, did I stop? Yeah. In your packet today... Oh, wrong day. Hold on. Pages 25 to 26 in your packet. I want you to work on numbers 1 through 20 in here today, right now, because tomorrow you're going to work on the other half of this worksheet, and then at the end of tomorrow you're going to give me that whole worksheet to do, okay, for me to grade. So, I'm telling you this now so that tomorrow, if you don't do anything today, you're going to have a whole lot to do tomorrow, Okay, so do 1 through 20 today. That way tomorrow's not as bad for you. Okay? It's just 1 through 20. That's all you're doing for the rest of class today. Okay? Yes, I know it's a lot. I know it's a lot. I am willing to take the textbook homework off if we are all working in class. Okay? If we are not all working, though, I will leave that textbook homework on there. Nope, we're not. I just made a deal with you. I said if you're doing work, no textbook homework. Nope. The only way you get better is if you practice it. That's the only way you're going to get better at it. Okay? Okay? So do 1 through 20. Okay? This is due tomorrow at the end of class. Okay? After you have the second half of our work. But yes, we're putting on a lot of work one by one. So you've just got to stay on top of it. Don't put this all off to study Sunday night. It's not going to go well for you. Okay? You've got to do little by little. We're in the home stretch. You guys are almost to summer. Finish strong. Okay?
4.1 test.
Yeah. Let me freeze my screen. And I also need to stop recording.
It was good.